Okay, I want us to get started by working on some of the problems that or the graphing problem that we had looked at last time in class. For any of you who missed the lesson, I do apologize. Seems like apparently there was no voice that came through on the video. If there's something that you need explanation on, you'll have to let me know, and I can create another video and put it out there for that. And I may even try to do one anyway for you that kind of goes over some of the things. But we did at least start by doing some sketching. And there were some steps that were given for sketching, and those I wrote out in class, but you also have them on that test review, which we'll talk more about when we get back to class on Wednesday. But for right now, let's go back and look at the one graph that we had started, and that was that y was equal to x plus 3 over x minus 2. And I'm kind of going to redo some of the steps that we did in class. The first thing we did was try to find the asymptotes, and we always started with the vertical. They were the easiest to do because that is where the denominator would be equal to 0. Here we just need to solve for x, and we're going to add 2 to both sides, and we get that x is equal to 2. And so it makes it real clear. We don't have to know whether it's an x equal or a y equal. It automatically works itself out. Remember I said that you will either have a horizontal or an oblique asymptote. You will not have both. The only time you're going to have an oblique asymptote is when you can do a long division, specifically when the exponent on the top is higher than the exponent on the bottom. And so when it comes to these, you're either going to have a horizontal or an oblique. You cannot have both. Since the exponent on top is not higher than the one on the bottom, we're not going to get any kind of oblique, but we probably will get a horizontal. Let's look at horizontal how it works. First off, we're going to look at y equals the limit as x approaches infinity of our function, x plus 3 over x minus 2. Of course, if I try a direct substitution on this, I am going to get that indeterminate form, which is infinity over infinity. So what we're going to do instead is come on in and divide through by the highest power of x. So this looks like the limit then as x approaches infinity of x over x plus, 3 over x divided by x over x minus 2 over x. That's equal to the limit as x approaches infinity of 1 plus 3 over x, 1 minus 2 over x, sorry about that, and then anything that's stuck with an x in the denominator, again what's happening is we're taking a number and we're dividing it by a really big number, and it can be big negatively or big positively. It makes no difference. These quantities are going to go to 0, and the only thing we're going to be left with is the 1. So we get, sorry about the color on that, we get that y equals 1 then is a horizontal asymptote. Okay, for step 2 of our process, we need to then test our horizontal asymptote. We got y is equal to 1. We need to make sure that the graph is not going to pass through the horizontal asymptote. The only way to tell this is to go back to the original function. We had y was equal to x plus 3 over x plus 2. And everywhere there is a well, actually what we're going to do is we're going to put in the y. If we get back a value for x, then we know that it passes through that point and therefore will cross the horizontal asymptote. If not, then it will not cross the horizontal asymptote. So we put the 1 in for y, and then we solve the resulting equation. In order to solve this, the first thing we need to do is to get rid of the fraction. Oops, sorry, I got my number wrong on that. Should be an x plus 2 at the bottom. Let's try that again. So the first thing we're going to do is to multiply here by the denominator, which is x plus 2. And as long as we do that to both sides of our equation, we're good to go. Distributing that 1 through on this side, I'm going to get that x plus 2 is equal to, notice that it cancels over here, and that gives me x plus 3. And then if you go through your process and solve this, you might subtract 2 from both sides, and you get x, those 2's go away, is equal to x plus 1. But then if you try to move the x's onto one side by subtracting the x from both sides, you get 0 equals 1. And that tells you there is no solution. And the only time that we will cross that horizontal asymptote is if we get an x value. If we get an x value, then it will cross at the ordered pair, whatever we get for x, and y is 1. But if not, it does not cross. Okay, Okay, so let's come in here, and we're going to go ahead and let's see if I can get me a good thick point here. I'm going to go ahead and draw in my asymptotes. I had an asymptote at x equal to -2 and at y equal to +1. Okay, and I'm going to keep coming back to this page to add things on. Let's go ahead and do points. So we have the ordered pair 0, -3/2, which is about sitting right there, and we had the point 3, 0. Now, we can check the symmetry of this, and you did have some exercises where you were required to find the symmetry in graphs. I'm going to let you guys go through and do that. If you have symmetry, it's going to help you in the way that this thing looks. But the final step of this is to go ahead and look at what's happening with the graph. And when we do that, what we're going to do is we're going to look at the splits that we see along the x-axis. In other words, and I'm going to write on it with this and I'll take it back off after I'm done, but we have two portions of the graph. I have this portion of the graph and I have this portion of the graph. And what's happening is I'm looking at the straight lines or the lines that split my x-axis. And the only way my x-axis splits is right here at this point, right there. So I only need to figure out what's happening on each side of that. Now, let me get rid of all that mess here so we can work with it. So again, you can see the two sides. Now, over there on the right, when you do this, what you got to understand is one of two things are going to happen here. Remember, we couldn't cross any of our asymptotes on this. So our graph is either going to come down in this direction and do this kind of thing where it hugs those asymptotes, or it's going to come across in this direction. What we would normally do if we didn't have any points to pick, we didn't have points already plotted, is we would just pick some value here and see what the value of x we get is. If I get a point that's up here on the top of the graph, then I know it has to have the look that we see on top. If I pick a point like 0 and it gives me a point down on this portion of the graph, then I know that it has to go the other way. Well, in our case, and let me get rid of some of that stuff, it's made easy for me because I already have the 2 points that I know that this thing needs to go through. And as a matter of fact, I know that my graph has to go through those 2 points right there. Remember, we found those as our intercept points, and since we need to hug the asymptotes, remember, you never get really close, but you never really cross them, it's going to do that. Now, coming here on the other side, again, I've got to look up in this region. That is, see if the graph exists up here, in which case I would assume it's going to do this business. Or see if the graph exists here, and in which case it's going to do this kind of business here. Again, hugging those asymptotes. So how would I do that if I don't have any points already there? Well, I'm just going to pick a point and go ahead and calculate what it's going to be there. And depending on what point I get, I'll know exactly where that graph is going to wind up laying. Let me show you what I mean. To pick these points, we're always going to go back to the original equation. Our original equation, sorry about the color on that, was y is equal to x plus 3 over x plus 2. And what I'm going to do is I'm going to pick a value of x on this side of the equation. And remember, I defined this side here. So you can pick any of these values of x. That's -3, -4, -5, -6, any of those values you want to. And when you pick those values, it's going to give you back a coordinate or a point. And depending on where that point ends up, tells us where we're going to plot this graph. Let's go ahead and find one. And I'm going to just do an easy one. Why don't I just let x be equal to, ooh, sorry about the color on that. Hang on, let me get my right pen here. Let's let x be equal to, I don't know, we can try -3. We're going to place that back into our original equation to get our y. Y then would be equal to -3 plus 3 divided by -3 plus 2. I get 0 divided by a number, which tells me y is equal to 0. Now that gives me the ordered pair -3, 0. So when I come in here and I plot -3, 0, I can see which side of the graph it's sitting on. Remember, when we were doing this, we were trying to figure out, does the graph do this kind of thing? or does it do this kind of thing? Again, hugging those asymptotes and never touching them. But based on where my point ended up, I can clearly see then that what I have is a graph that's going to, let's get the right color here, it's going to come close as it can to that, hugging it, and then passing through that point, hugging it on the way down. Some of the other pieces that we need now. The next step says we need to find the intercepts. To find the intercepts, we go back to our original equation. Y was equal to x plus 3 over x plus 2. And for the y-intercept, we let x be equal to 0. And when x is equal to 0, you get y would be equal to 0 plus 3 over 0 plus 2. So y is equal to 3 halves. That gives us the ordered pair 0, 3 halves. Next, we need the x-intercept. And to get this one, we let y be equal to 0. So we get 0 is equal to x plus 3 divided by x plus 2. Once again, anytime I have an equation that is a rational function, that is a fractional type function, and I want to solve it, the first thing I want to try to do is get rid of the fraction. And I can do that as long as I go ahead and multiply that by both sides. Of course, distributing across here with a 0 is just going to give me 0 on the left-hand side. But the x plus 2's cancel on the right, and I get x plus 3. Then by subtracting 3 from both sides, I get that x would be equal to 3. Remember, we let y be equal to 0. We got x is equal to 3, so we have the ordered pair 3, 0. Now we're going to go back to our graph and plot the